Hi, and welcome to Feature Fridays. My name is Guy Bartram. I'm the Director of Product Marketing in our Cloud Services business unit. And today I'm joined by Sachi. So Sachi, welcome back. Do you want to just introduce yourself and your role to people who haven't seen you already?
Yeah, sure. Hi, everyone. I'm Sachi. I'm Technical Product Manager with VMware, focusing on Tanzu products, integration with VMware Cloud Director. And let's get started.
Yeah, so we're here to talk about that integration today with Tanzu products from Cloud Director, which is all via container service extension. And the reason you wanted to do this today was because you've been, monitoring the Slack channel and listening to feedback from customers and partners and from our field, and sort of fielding a lot of questions regarding container service extension, its usage, its installation, its configuration afterwards. So great idea to kind of have a bit of a refresh around that, and also to kind of pick your brains on some of the aspects of the packages that are supported and stuff like that. So why don't we dive straight in, Sachi?
Sure. Let me start the screen share. So here we are mainly going to talk about container service extension. And today I'll be diving into what is container service extension, what are the user personas involved from the perspective of cloud provider operations. And then we'll go over Tanzu Kubernetes Grid and how it is offered with container service extension. And then we'll touch upon some of the use cases with container service extension.
Okay.
So first of all, it's a container service extension is an appliance that you can install on top of your existing VMware Cloud Director infrastructure within a provider managed organization.
Mm-hmm.
And you can offer two types of Kubernetes as a service offering. One is for Tanzu Kubernetes clusters, and the second one is open source Kubernetes clusters. So these are two different use cases. The Tanzu Kubernetes clusters offer feature-rich Tanzu Basic and Tanzu Standard compatible Kubernetes clusters, and they are multi-master. They have VMware supported packages, VMware supported OVFs, and a lot of automation from a load balancing point of view. And CSC open source Kubernetes clusters, these are OVAs maintained by, these are open source Kubernetes OVAs, and you can use them to test some of the applications quickly, or for POC point of view, you can use those clusters. And the value add for Kubernetes container service extension is that you can plug it into your existing VCD infrastructure, and using your using the customer's existing resources, they can start offering Kubernetes as a service. And yeah,
it's free, right?
Yeah, it is free.
So, yeah, and Tanzu Basic is now included in Flex, so that's also free to service providers to consume.
Yes, that is correct. So TKG clusters or Tanzu Kubernetes clusters provisioned through CSC can be Tanzu Basic or Tanzu Standard. So you can achieve both editions using the container service extension.
Cool. Okay.
Yeah. So there are three main components to container service extension. One is the CSC server. So provider admin is going to install the container service extension service on top of on the CSC server. And the second one is CLI plugin. So CLI plugin is a small, lightweight plugin that can be used to interact with the Kubernetes clusters installed with help of CSC server.
Mm-hmm.
So think of customer organizations, user, or tenant admins. They can simply use the CLI plugin to manage the life cycle of Kubernetes cluster and perform different operations on top of it. So you can create cluster, upgrade cluster, you can scale up cluster, or you can manage the access of the Kubernetes cluster using this lightweight CLI. And the look and feel of the CLI is almost like kubectl. So developers who are heavily operating with kubectl, it's easy for them to use this plugin. And the last one is the UI plugin. UI plugin is embedded within VMware Cloud Director appliance. So all providers have to do is to publish that plugin to its customer organization when needed.
Yeah, super easy. We've done a couple of feature Fridays on that already, and that's download the plugin, install the plugin, and then deploy, as you say, for the tenant organizations, and you're done.
Yep. Yeah. So I'll quickly go over the components for provider, like how to, what to do when you are onboarding or installing container service extension. So as a provider administrator, I'm going to install some base OVF. It can be any operating system. So you can install it on Photon OS or on Ubuntu or on any Linux VM, even Windows, to install the container service extension. The resource requirements I'll go over in detail later on. So this can sit in provider managed customer organization on VMware Cloud Director, and it needs some of the requirements, like it needs to have outbound internet connection to download and manage some of the container service extension packages. While installing it, then you can probably secure it afterwards. So once you have to install it, you can get the package from the GitHub and then provide the config.yaml values. This config.yaml is basically one of the, it tells about infrastructure requirements, like CSC server is going to talk to VCD appliance, and then how many underlying vCenter infrastructures are there. You import the templates to the container service extension. So here we have introduced this command template import. So here you can import the TKG template to offer Tanzu Kubernetes as a service. And then you can run this as a service within that container service extension server. So
how often do those templates change, Sachi? Are they like every release of CSC and then there's an upgrade procedure for the templates?
Yeah, so you can, every release we introduce newly supported templates. I'll go over the supported versions later on in the session. So right now we are at CSC version 3.1.2, and we are supporting TKG version up to TKG version 1.4.1. So whatever TKG version 1.4.1 templates, so I think it's around 1.21, Kubernetes version 1.21, 20, and 19. So these three are supported. So all these can be downloaded from our official VMware download site, and you can upload it on the shared catalog on the VMware Cloud Director CSC portal.
Okay, makes sense.
Yeah. So once you have done that, CSC is going to communicate with Cloud Director API and using the MQTT. We are not using AMQP anymore. We don't need to install any additional RabbitMQ or any appliance.
Yeah.
And
we
then
got rid of that a few versions ago, didn't we?
Yes, we did. And then once that is done, once you have started the container service extension server, and it's registered with VCD, you can start onboarding your customer organizations. So this command is going to help you enable the customer organization, and then you have control over which OVDCs you want to enable or provide Kubernetes offering. And then we need some additional write bundles to onboard these customers, purely because we have introduced a lot of offerings on different Kubernetes plugins like container storage interface, cloud provider interface. So all those requires access to underlying infrastructure of VCD to automate some of the things. So you have two ways to do it. One is through CLI. I have noted down the commands over here, or you can simply create a user role within the cloud provider organization and then publish it to different customers.
Okay.
Yeah. So, and then once this is done, you can also publish the UI plugin using the customized portal to onboard UI part of it. So once this is done, all in this example, my org1 will have now a UI plugin for container service extension. And so that was for the providers. And now I'll walk through the tenant user experience. So once customer admin or tenant admin is onboarded, they can install this VCD CLI, the CSC CLI part that we spoke about, and then they can start using it on the local machine. So there are some users who are not going to log into VCD at all. They can simply use this VCD CLI, get a sample of the cluster configuration, and then create a cluster. And we'll get the same outcome as a UI plugin. So in this example, I'm creating some screenshot where I've created one cluster with the TKG version 1.21. The other thing is through UI plugin or through CLI, they can download the kubeconfig and using kubectl locally, they can start accessing the Kubernetes cluster for and then they can just access the Kubernetes cluster. Now,
that's quite a nice little feature, isn't it, to be able to download that kube config and then use that with all the connection details that you need and all the configuration items.
Yeah. And one thing I would like to add is that if VCD is having multiple sites, CSC supports multiple sites operation. So you can have multiple locations, and then you can manage those from the same UI interface for ease of operation. And that goes same for the number of underlying infrastructures. So if you have, say, two vCenter servers configured on VCD, CSC manages or handles that situation as well.
In the case that you've got a remote site with, a secondary data center with VCD up and running, I assume you have to do the deployment there as well, right? For the UI component, the server component, or.
So we don't support multiple CSC server configuration with single VCD, but if you have, say, multiple sites, backup sites, I think CSC will be able to look at them.
Okay, without you needing to deploy CSC in those sites.
Yeah. The next one is the user personas. So there are, like, for any VMware Cloud Director hierarchy, we have 3 different user personas for this. One is provider admin, where provider admin is responsible for installing and managing the container service extension server. They'll manage the config file, which provides like infrastructure specific details like which storage, which underlying infrastructure access details to those. They'll manage the templates offerings to customer organization. So if a new version of CSC or new templates are available with the new version, they'll have to manage those for the customer. And the last one is manage the permissions and rights from the provider portal.
Yep.
The next one is tenant admin role, where tenant admin will be mainly responsible for creating and managing Kubernetes cluster for their developers. And if depending on the structure within the customer organization, they can have create different users who can create and manage Kubernetes clusters as well.
Okay.
And yeah, go ahead.
Yeah, just on the managed lifecycle piece of TKG. So how much of an overhead is that? I mean, from a point of view of like each CSE version comes with new templates potentially. So there's going to be an element of upgrade, but they don't necessarily have to upgrade, do they? They can stay on the old templates.
Yes. So right now, TKG templates are managed by provider admin. Upgrade feature works for the open source Kubernetes components. So that's a single click upgrade support. So if a user is running or within customer organization, if they have a cluster running on older version, they can, using UI or CLI, they can simply perform single click upgrade on the Kubernetes cluster.
Okay. And those are, is there any application downtime associated with the upgrades? I think that's one of the key.
Yes. Yeah, so that's the standard Kubernetes upgrade practice that they have to consider, where they can back up their workloads or move their workloads to different applications to perform the upgrade, because sometimes there will be disruption on the clusters. So you can, on the UI, when you are performing an upgrade, you will actually be notified if there is going to be any impact to perform the upgrade, and you can make a decision based on that.
Okay, cool.
Yeah. And for the developers, they don't have any, they don't have to have any knowledge of VCD. They can simply have the kubeconfig of the cluster created on the within the customer organization and access that cluster and manage the applications on top of it.
So just like they would normally, kubectl and off you go. Yeah.
Yes, that's all.
So the advantage here really is when the service provider is looking at this as a service to provide, is the the classic tenant admin, the operations team perhaps would be there, like usually delivering workstation, virtual machines or VApps and networking components, all this sort of stuff to the end users. But in this case now, the end user has become a developer. Developer doesn't care about the infrastructure side of it from a virtual machine perspective.
Yes.
They just want to use Kubernetes. So the operator just gives them a Kubernetes endpoint to go and play with.
Yes.
Yeah.
So for TKG, we have enabled an option to have inbound access to the Kubernetes clusters. So when someone from the customer organization, when we create a cluster, it's assumed that you have access to the VCD network or access to that Kubernetes cluster using that external facing network IP.
Yeah. Okay.
Yeah. So let's, I'll go a little deeper into server management aspect of it. So over here, we say any server, any operating system is supported as long as you are managing it using Python version 3.7.4. And literally these are the steps to install the container service extension. For the server operating system, the requirement is that you have 1 CPU and 2 GB memory. That's the minimum. but based on the load of based on how many clusters you create, you can increase the resources to run the CSC server.
Right.
And you can configure HA on the vCenter server to provide high availability of the server itself.
Mm-hmm.
But if the server is down, for example, the running Kubernetes cluster will not have any impact because they are their own entities up and running.
Just like if VCD goes down, you can still access your virtual machines and your VApps and everything else. Yeah, same thing. Okay.
Yeah. And the next one is that CSC server will be installing within that organization. You will be installing some to access the CSC server. You will require some inbound connectivity to your server while installing it, and outbound also, because you will be downloading some of the templates, you will be downloading some of the packages, you'll be downloading the CSC appliance itself.
Yeah.
So for that time being, you'll need some outbound and inbound internet connection.
Sachi, is there any way, I'm just trying to think, is this is getting installed in the PVDC or in the provider virtual data center?
So the best practice is to create provider managed OVDC. So you'll have, say, for example, you will have a solutions organization, and you have your own OVDC, and within that you create your own dedicated, not dedicated, but for that tenant you create your own network edge, provide some storage to run the CSC server.
So, okay, so it's like an internal org VDC for the provider to use to deploy into. Yeah, okay. That makes sense. And is there any way, just for isolated environments, is there any way to point it to like an internal proxy or something like that to download the container service extension appliance?
We don't have proxy as of now, but we do provide a proxy for running the Kubernetes cluster to access the outbound sites. So outbound connection for Kubernetes is supported, but right now, just for the time being of while you are setting up your server, I think you need internet connection.
Okay, all right.
Yeah. So once that is done, so yeah, these are the steps to actually manage the or install the Kubernetes CSC server. And then once you have set up all the infrastructure details, you can actually run it as a service. Based on your OS, you can define your service and start and manage and upgrade whatever service operations you would like to do. Yeah. So that was the provider portion of container service extension. And now I'll move on to Tanzu Kubernetes Grid with CSC. So we know the advantages or features of Tanzu Kubernetes Grid, that we get a multi-tenant isolated Kubernetes cluster within VMware Cloud Director like infrastructure. We have some of the pre-integrated components on the TKG cluster, and then these are validated and maintained Kubernetes templates that we are leveraging with container service extension. Now, I'd like to take some opportunity to talk about like why we decided to have CSC to offer TKG on VCD. So recently we released version 3.1.2, and these are the TKG versions that we support with CSC, and then each version has their own supported KTs or Kubernetes version. So if we go by like support the latest, these are the supported Kubernetes template versions that you can upload to CSC and offer it to your customers.
Got it.
Okay. And then to download the OVFs, you can go to the Customer Connect portal and then select the Tanzu Kubernetes Grid and select the version and get the OVAs. Right now, we support all the Ubuntu operating system based OVAs with CSC. And then, like I showed earlier, using the CSC template import command, you can upload it on a shared catalog on VCD to offer it to your customers. So why CSC? So VMware Cloud Director provides that multi-tenancy, secure or isolated infrastructure to each customer organization, and container service extension is built to support VMware Cloud Director. It has multi-tenancy at the core of service offering. So, and it's a plugin. So within your existing topology of your VMware Cloud Director, without making much changes, you can insert Kubernetes as a service using container service extension. So there are no like infrastructure level changes you have to do to offer CSC. So that's the value add for providers to go with CSC and TKG offering.
I think the only thing is you need vSphere 7 in terms of deployment out there for TKG.
That's for, so right now the requirement is that you need NSXT advanced load balancer to provide automated ingress load balancing for your applications. So in Kubernetes, we have service type load balancer to run, have access, inbound access to the applications running on the cluster. So we have automated that with NSXT advanced load balancer. So for that, you need NSXT advanced load balancer, and for automated ingress access to the Kubernetes cluster, we use NSXT unified appliance, and support metrics, or say product support, it goes same as VMware Cloud Director's interoperability matrix.
Yeah, and it's worth pointing out that NSXT advanced load balancer, the old AVI platform that's now integrated, is going to become more and more important and critical for providers to start looking at this in any case.
Yes.
And particularly in this, right, because we does a lot of ingress or egress web app firewalls, ingress firewall protection, and web app security as well, which I think is, when you're looking at container applications, is particularly required.
Yes, that is correct.
Okay, so you're getting TKG is, in a nutshell, it's VMware's kind of flavor of Kubernetes templates with all of the value add that VMware brings from the applications and the support and the automation. With VCD giving it a native multi-tenancy, CSC can't run without VCD. It is a critical component for CSC. Without VCD, CSC is nothing, because there's no plugin for it to deploy in, and no extension framework to deploy into. It doesn't run with TKG by itself on naked vCenter. It must have Cloud Director, and then you get all the layer 2 on network isolation and all of the goodness around the multi-tenancy and security. And like you say, there's nothing that a service provider needs to change. They just got to create a org VDC to deploy the CSC components into. They don't have to do anything in terms of really vSphere requirements. They should be up to spec in any case. They will have to deploy an appliance for the NSX advanced load balancer to give it that ingress automation and ingress access to the cluster.
Yes.
Yeah.
But if you look at it, NSXT advanced load balancer is not specific for Kubernetes. They can have it for other load balancing services as well. We are just leveraging that to offer ingress load balancing for Kubernetes cluster.
Sure, but then we automate the the Ingress access and potentially load balancing out the box for the new cluster?
Yeah, so as of now, you have to install load balancing components like Contour or Nginx today.
Yeah.
But once you have that, and once you start in, like after that, if you start installing all the applications, you will not have to do any manual load balancing configuration on your infrastructure by any way.
Okay.
Yeah.
Cool.
So with that, I'll quickly show, these are the packages that we have today on top of the TKG cluster we create using container service extension. So if you see, we have come up with, I'll have to change this out. So for VCD specific, we have come up with two plugins, the storage plugin and the provider interface. So those are CSI plugin will provide us persistent volume support for TKG cluster specific to VCD. And cloud provider interface will provide load balancing capability for VCD specifically.
Okay.
Yeah, and so this is something that will, this is like very 10,000 feet view of CSC server, its placement within VCD, VCD and its tenant resource. So you can see you are just adding one server over here and you are able to offer multi-tenant Kubernetes as a service to your customer organization, leveraging NSXT, load balancing, and underlying infrastructure.
Yeah.
Okay. And then with that, Guy, do you want me to skip this part, the cluster API, or we can?
You want to go straight to the demo now? We could get the cluster API next time. Perhaps that would probably be make more sense.
It's a big topic. So.
Okay.
Yeah. Okay. Inbound access. Okay. I'll start with the use cases then.
Okay.
Yeah. Or you want me to go to the demo directly?
I think we're going to run out of time pretty quickly here. So let's let's go for the use cases and maybe we do the demo next time with the cluster API as well.
Yeah, I can do that actually. That's fine because we have shown this earlier also. So
yeah, let's talk about the use cases then.
Yeah. Okay. So yeah. So next up, we'll talk about the access to TKG cluster, like how developers are going to access the Tanzu Kubernetes cluster deployed on the VCD customer organization. So while the tenant user is creating a cluster, they have this option to allow to create a expose this Kubernetes cluster if they are using the routed network configuration within their organization. This option is going to create a NAT rule to have inbound access to the Kubernetes cluster using the external IPs. So when you have available external IP addresses within your customer organization, it's going to actually dedicate one IP to access this Kubernetes cluster. And you can do this by applying using the CLI as well. You just have to provide this expose is equal to true option when you are creating the TKG cluster. So this is going to create a NAT rule, and then with that, it's going to provide us the kubeconfig file using that external IP. So you don't have to, like as soon as you have the kubeconfig file, using kubectl commands, you can manage your Kubernetes cluster externally. And this is especially useful for TKG cluster because we are going to access the plugins and install the container storage interface and the cloud provider interface on top of the TKG cluster.
Got it.
So this is kind of required for TKG cluster creation. And then once that is done, you will actually see one rule getting created automatically, which will be type DNAT to have inbound access. So it will be routed to your TKG cluster itself. And the next one is in CSC release 3.1.2, we introduced support for proxy configuration. So when you are installing the installing or upgrading your CSC server, within your config file, you can provide a specific configuration related to proxy server. So starting that point, when customers are creating Kubernetes clusters, they'll be using the proxy server to reach out to internet. So this is useful for customers who are using TKG cluster within like with restricted internet.
Specific networking layouts. Yeah. Okay.
Yeah. So that's useful. So now it cannot be like completely air-gapped, but at least you have now you'll be able to use a specific proxy to reach out to internet, making it more secure, like all your TKG clusters. So when you are installing some of the plugins or downloading some applications using Helm or App Launchpad, you'll have that support where you are reaching out to internet through proxy.
Mm-hmm.
And just a consideration over here that if you are running on CSC version 3.1.1, which is the older version, the last release, and you have say 3 clusters running created already up and running within their within customer organization, and when you are adding a new node to say one of the clusters, after your CSC is upgraded and you have introduced proxy, so the new node that came up is going to use proxy versus the old nodes will continue to work using the older configuration. Okay, and then the next one is the persistent volume support, which is the container storage interface. So what happens is provider is going to have some NFS storage configured and have storage policy within customer organization. And then when tenant admin is going to create a Kubernetes cluster and going to provide some storage class definition to access those persistent volumes. So this is example storage class. So we are just pointing it to this persistent volume, and then we are going to say that, hey, use use the storage profile to create persistent volumes on my Kubernetes cluster. And
is that
then
storage profile a VCD storage profile in VCD?
It's an existing profile within VCD.
Okay.
It can be iSCSI or NFS based storage profile on VCD.
Okay.
So yeah, and then we are just providing the storage policy from your VCD within the storage profile definition. Yeah. So once that is done on the Kubernetes cluster, when we define the storage class, we are going to be able to use that persistent volume to create more volumes for your applications on the Kubernetes cluster. So once the class is defined, they can simply just provide your application YAML with the storage class. Then it's going to claim a piece of that volume for that application. And then once the claim is done, that remains until we actually go and delete this volume claim and the volume itself. So regardless of the status of the pod on your Kubernetes cluster, this volume is going to remain present on the Kubernetes cluster. And it can be, because it's dynamic, you can actually just apply the definition for the volumes, you can change the volume claim based on your requirements of your application.
That's pretty cool. That's pretty cool. Yeah. So
Yeah.
a service provider can define different storage policies for different types of applications, perhaps for customers, and
Yes.
then make them available. So does the I say it's the tenant admin who defines that storage class. Okay.
Yeah, I mean, any Kubernetes user who has access to manage the storage class, they can do it. But this is a convenient or conventional way of defining that who is going to manage the storage class and who is going to access it. So
yeah,
this is one of the example. If developer has all access to the cluster itself, they can go ahead and create a storage class also.
yeah. So it's up to the provider to perhaps do an bronze storage on standard like spinny disk drives and gold storage on SSDs of particular speeds. That would be offered automatically to the organization in any case, right? They'll be able to choose which storage class. But then what the tenant admin can do here is he can include them in his storage class definition.
Yes.
So the developer can then, cool. So they could put production apps on fast storage and developer apps
exactly.
on, got it.
Yeah. So your cluster can be running on different policy than your database that's running on your cluster.
Yeah.
That's cool. Yeah.
That's very cool.
Okay. And here, okay, let's skip that part. Okay. Next one is Ingress load balancing with NSXT Advanced Load Balancer. So here we are leveraging how NSXT Advanced Load Balancer is integrated with VCD. So we assume that our cloud provider has enabled or integrated NSXT Advanced Load Balancer with VCD, created external IP pool for and allocated some IPs to customer organization, and then also onboarded customer organization to load balancing service. And the tenant user is going to do only two things. One is install or upload the certificates on VCD to provide secure ingress access, and install ingress controller like Contour or Nginx. You can do it using Helm or even using App Launchpad on top of your Kubernetes cluster. And I'll quickly walk through some of the screenshots over here. So this is the provider view where you add the NSXT Advanced Load Balancer controller. You have defined the clouds, and you have defined the service engine group type within the NSXT Advanced Load Balancer provider portal. And then on the customer portal, you have enabled it. And then you can see these four options to leverage the automated load balancing. So these are the prerequisites for load balancing to work. Once this is done, and once a customer starts installing applications, everything will be automated this point on. And that's about it.
So you've got load balancing for it's automatically inherited then for any applications that are created, is that right? And it would depend on the service group and the configuration of that service group and what mechanisms it's using, etc.
Yeah. So we have two options. One is dedicated, one is shared. You can use either. In this example, I'm just trying to show over here that you can have two applications running on your cluster, which is using, for example, one is WordPress and one is Prometheus. It's going to actually use two different certificates for ingress access to these two applications. And then each application is going to be tied with load balancing IP. Depending on your allocation, it's going to be tied with some external network IP, external facing. So and then it's going to use any ports, like for example, Prometheus uses some non-default ports. So the load balancing service will actually take care of your service port numbers dynamically on load balancer as well.
Got it.
Yeah. And with that, so these are some of the just examples to how you're going to see NAT rules for your external IPs mapped to internal IPs. And the next one is how they are created, the virtual services are created and mapped to the service ports. So in this example, they are all 8443, but it can be really anything.
Yeah.
Any port running on your service. And that's all I had actually for today.
Okay, so we've seen a variety of things there. We've answered some questions around why CSC, why Tanzu Kubernetes Grid. We've looked at some of the version and interoperability. We've kind of discussed the deployment, the components of CSC, and some of the use cases, which particularly around some of the advanced load balancing stuff, may be new for providers if they haven't looked at the NSX Advanced Load Balancer yet. And I believe the NSX Advanced Load Balancer, the basic version is also included in Flex. Is that right?
Yes.
Yeah. Okay. So there's no cost for using that.
Yeah. So for L4 level load balancing, you don't need additional license to provide it. Even with Kubernetes, it's included.
But there's a significant amount of value add, isn't there, in the NSX Advanced Load Balancer? When you go up to layer 8 and layer 7 kind of load balancing services, there's a lot of additional functionality that you can provide there as well.
Yes.
Which is definitely worth providers looking at in any case if they haven't seen it before. It's a good value add. Okay, and Sachi, next time we're going to dive into some more of the demo, I guess, and look at some of the kind of real specific nitty-gritty details.
Yes, so next time we can look at the provider experience to onboard a customer, and then from developer point of view, we can create a cluster and prepare cluster so that if anybody can come and install applications, and we'll deploy demo applications to see how things work in action.
Excellent. I look forward to that. Sachi, thank you very much for your time today. Really appreciate it. It's been great to have a kind of revamp on CSC. It certainly refreshed my memory about it. So thank you.
Yeah, thank you.